Hey guys, it's Dustin here with DG's Pro Tech in Listowel, Ontario. You know, it's been a little while since we've done a couple DG's TV videos, so we thought we'd hit you up with one all about 6.7 Powerstrokes. Okay, so 6.7 Powerstrokes. Well, let's back up again like we always do. We've got one apart in the shop today. We thought it'd be a great opportunity to go through the overview. So back in Fordland, 2010 was the last year of the Ford Navistar family of engines that came up. And in 2011, we were blessed with the 6.7 liter Powerstroke. This is a new engine. This is a Ford birthed engine, and it shares absolutely nothing with the previous generations of Powerstrokes, okay? Like absolutely nothing. Now, here we are in 2023. What are we doing talking about an engine that's 12 years old? Well, the beauty of that is, for those diehard Powerstroke guys, go back to 7.3 land. This engine has now been in production and used by happy customers everywhere way longer than your international 7.3 that ever was. Food for thought. So we're going to walk through and do some overview on this. Then we're going to talk about the different generations, because there are, in my opinion, 3 generations of this engine, and they just keep getting better. But we'll talk about some changes and some common concerns as we go through with that. Okay, so let's talk quickly about some of the basic flow that is different in characteristics, and I'll try and keep it as short and sweet as I can. Okay, so every single 6.7 liter Powerstroke engine, a couple things that are different than many. First of all, it's hard to see with this one fully assembled, but your block is now compressed graphite iron. That's different than cast iron. The weight reduction is quite increased. The strength is also increased. And so with better power to weight and lots of strength, those are all good things. We can increase power and torque loads for this engine. Other interesting things, similar to Duramax, again, hard to see, we've got aluminum cylinder heads now. Still 4 valve per cylinder, but aluminum this time. Again, weight reduction makes for decent power to weight with these. It brings in interesting things within our head gasket sealing, very similar to what we have in Duramax land. However, Ford did a really good job. We went back to 6 bolts per cylinder in these, so we don't see head gasket problems typically in the 6.7. Can't tell you how many times I've had customers call in and say, I've got a head gasket problem in my 6.7. You sure? So anyways, 6 cylinder head bolts holding down per cylinder over the average of it. Still 4 valves per cylinder, 2 intake, 2 exhaust, except different than on our 6 liter 6.4 and many other engines, including the 6.7 and 5.9 Cummins. We have 4 individual rockers that push on individual valves. So I'll see if I can get you a shot of that in a little bit. But basically, you can picture on most engines, you have one rocker pushing a valve bridge for 2 valves and another rocker pushing another valve bridge. Instead, we have 4 independent. Now, one of our previous videos on the 6.4, we talked about rocker fulcrum tips wearing off due to lack of lubrication by design. What did Ford do here? Again, every single issue that they had that was not addressed on previous engines, they took care of. There's actually an oiling manifold inside there to oil that valve train. The lifter concerns we saw in 6 liter 6.4, which is the same part number, even back into 7.3s, we also don't see that in the 6.7s as well, because they've gone to a really neat hydraulic lash adjuster, one for each individual valve inside of a lifter, where you have your lash and your roller lifter as 2 separate components, one sitting inside the other. Seems complicated, but when you see it, it's actually really simple and super ingenious. Simple, ingenious, reliable. See the trend we're going on here? Let's talk about cooling systems for a second. Interesting, and this is not the only vehicle to have this, but it's the first one we've seen in light-duty diesel. This is your primary water pump, and this is your secondary water pump. So we have 2 water pumps in this engine. Now, your primary system and its cooling system runs at a more normal, or what would you seem a very average, I'm going to call it the primary or high temperature cooling system, where we're dealing with a thermostat set around 195 degrees, very similar to anything else that's out there in the automotive internal combustion world. Interestingly enough, though, we got thinking is, in previous generations, we had large single temperature cooling systems like we saw in the 6.4. Humongous, thick, giant rads, big cooling fans, run everything hot, and life is good. Instead, we have some issues with that. Some things run too hot, some things run too cold. So for instance, on this, we run a second water pump, a second radiator, second coolant overflow bottle, literally there is no connection point between your primary high temperature cooling system, which is cooling engine, turbocharger, half of your EGR cooler, and other high temperature, obviously engine block, heater core, and other high temperature spots. And then you've got your secondary, which is a smaller system that's going to run things at about half that temperature operating. So we're talking about transmission cooler. We have a liquid intercooler, which we'll talk in a bit. Fuel cooler, the low temperature side of the EGR cooler. Those things all need a lower, lower temperature operating range so we can set them with different thermostats. Speaking of thermostats, this truck has 5. 2 at the primary in the high temperature and 1 in its side tank radiator. And then in the secondary system, there's 1 in each end of the side tank of its radiator. To be able to control that temperature and flow, because as you've heard in previous videos, that's the name of the game, okay? One of the other real neat things, and we'll redirect for this shot in a minute, is the fact that the exhaust manifold and intakes are now reversed. So we have our exhaust manifolds in the valley directly below the turbocharger where they have very short runs to get a quick spooling turbo. And then on the and the heat stays generated in the center. And then on the outside, we have, you'll notice, no exhaust manifolds because we have good airflow. We keep our intake temperatures cool after we've already cooled them. So the intercooler no longer has to work as hard to lower a temperature that's going to get hot being near the turbocharger. Really ingenious. All right, so let's talk a little bit. I did mention it before about the unique intake system on this truck. Now it's hard to see, but this is your cylinder head, and this from here up becomes your valve cover. So with my handy dandy pointing to, you can picture inside here you've got your valve train. So your rockers, you've got your come pushing down on your valves, and the oil spraying manifold inside there. And you'll notice this cast port running down here. That's actually separated cast ports running down, and this one would be going to this back cylinder on this passenger side cylinder head, but they're actually cast in through there. Now, these padded areas are just noise isolators, but you have to trust me there that each injector for each cylinder is in there, and these are Bosch piezoelectric type crystallized injectors. Nothing we haven't seen before. Definitely being on the low maintenance side within this engine, we don't see a lot of injector failures unless there's contamination. Talk about our EGR cooler there for a second. So unique, we moved the EGR cooler up on top of the valve cover in this truck, which is great to see. It's easily serviceable. And that's actually another interesting point, was if you actually undo this back plate, and there's a front plate as well, there are 2 cores within this hooked to one end plate, which means we have a path of which the EGR cooler can go through, turn around 180 and come back up through to cool those exhaust gases as necessary. Now, on the front of the EGR system here, we've got your EGR valve, which controls whether or not exhaust flow enters the EGR cooler. And then on top here, we also have this bypass valve, which will allow the EGR gases to either A, go directly from the EGR, from the EGR valve, hot exhaust gases into the intake stream, or B, we can open up that valve, which is vacuum controlled, and we can run through our cooler, cool those exhaust gases before we introduce them. Why would we need one or the other? Depends on your ambient temperature and other factors of which this truck is monitoring all the way along. So neat EGR cooler, totally serviceable. Cores can be changed out, housing stays the same, fairly robust on this design. They're getting better every generation on these. Very similar design you'll see all the way up through all 3 generations of the 6.7 Powerstroke. From the back side of this engine, we get a couple other good areas of seeing. Here's your exhaust manifold ports coming out of the side of these beautiful aluminum heads. So obviously our exhaust manifolds have very short runs. Now, missing from this truck right now, we're gonna go over it in a minute on the bench, is the turbocharger. It sits nice and slung low. It has its left and right exhaust manifolds at drive, and then its exit comes nice down to the rest of the exhaust system you see here. While the turbocharger is out of the way, we can see all of our fuel plumbing and our injection pump. We're using common rail Bosch injection system here, and we're using a CP4. We'll get into the CP4 in the failure section, of course, but it is driven directly off the camshaft gear, not a belt-driven design at all. Decent engineering setup for where they've put it. One of the other things we're going to talk about in a bit, crankcase ventilation. And I'm going to maybe touch starting on some of the concerns. The crankcase ventilation system, this is a 2nd gen, but we'll talk about the generation changes. There is a few running changes on superseded parts for the crankcase vent filter system. Of course, this is catching all of your pressurized exhaust blow-by that a natural engine is going to make. It tries to separate the oil from the misted pressured gases and allow it to then flow back into the system. Earlier models had some problems with it getting saturated and not being serviced. They are not serviced for life, guys, so that is something we recommend here in Canada in our operating ranges. Every 100,000 kilometers, 60,000 miles for our American friends. Beyond that, you're pushing it. I know that sounds maybe a little short, and that's not a factory specification. That's our specification to keep you from having to do seal replacements for oil leaks, which we'll talk about in a second. Again, on all generations, up until 2019 was the last year, you're hooked to a big, beefy 6-speed transmission. It was a new transmission also in 2011. Great transmission. It was considered, it's called a Torque Shift 6, so it's a newer version of the 5R110. This is your 6R140. A great shifting transmission, gives us very little trouble, and of course, a corresponding transfer case with that. Our lift pump system, still running dual filters, one at the tank frame rail area, one up right here on top, and there's a couple year changes and different part numbers for that, but the same general design all the way up through. We're bringing lift pump pressure up in ballpark 40 or 50 PSI up to our injection pump, and our injection pump will take minimum 5,000 at idle and right up to 28,000 and pushing that 30,000 with tuning mark from that Bosch CP4. All right, so talking about generations again. Generations, typically the Ford doesn't call them generations. We're going to call them that for all intents and purposes. Your 2011 to your 2014, we're going to call generation 1. Okay. Now, what you also have to understand is there's differences between what Ford calls a wide frame, I call a pickup, or Ford calls a narrow frame, I'm going to call cab chassis. Okay. So slight variations between those two in regards to the EGR valve material and turbocharger complication design. Other than that, almost identical powertrains. Okay, so again, generation 1, we're talking GT32 twin scroll turbocharger. You can also link our VGT turbo design video. We show all the generations and their breakdown and their problems with that. But your 11 to 14, we're using a Bosch CP4 pump. Once you jump to generation 2, which starts in 2015, we have a Bosch CP4.2, a little more output and flow capabilities. Those are retro interchangeable, nevertheless, still something to note. Turbocharger, we mentioned GT32 on your 11 to 14, twin scroll, which means 2 compressor wheels back to back, running off 1 turbine wheel. Still running VGT in the exhaust vane side to give us good spool up on both low and lots of flow on the high RPM. On your pickup, so that's your 250, 350, and pickup 450s, you're going to find you also have a wastegate in generation 1. Okay, once you jump, but the no exhaust brake design in generation 1. So no button on the dash like some of their competitors to control exhaust brake. That was already complicated enough with VGT, wastegate, and twin scroll compressor design, which means it has 2 airflows going into it. Again, refer to the video. Other than that, most things stayed very, very similar. A few small plumbing changes once we jumped to generation 2. Talking about generation 2. Generation 2, we're going to say is 2015 to 2019. Same engine, same transmission. As I already mentioned, we go to a CP4.2, slightly more flow capabilities from our injection system. Failure rate stayed about the same. Turbochargers, we go from that very complicated twin scroll to a more generic, but still larger compressor wheel design. Single compressor, single VGT scroll design turbo. Very similar to what we've seen on 6 liters and on Duramaxes of many generations as well. We're running a cage style VGT design. The reason to go to the GT37 design was the fact that it was less prone to failure because you had less engineering things going on. Also less susceptible to an overspool type bearing failure, which we saw a lot of on the first generation. Not epidemic levels, but still saw enough of them fail. Interesting to note, if you are a generation 1, 2011 to 2014 Powerstroke owner, do not despair. When and if your time does come with a turbocharger failure, a company like DG's ProTech can help you out. There are retro designs to put your second generation turbo into your first generation Powerstroke if that's what you're looking for reliability. A little bit of emissions compliant tuning will get you to a point where that's going to work seamlessly. Also interesting to note, the GT32 does spool slightly quicker than your GT37 in your second gen, typically with a little bit of tuning, and honestly it's very low noticeable, but it is interesting to note. Once we get into generation 2, so that's 15 to 19 again, I'll say it again, we do also get in our pickup designs, we get a button. Now we have a controllable turbo exhaust brake. Again, with this little simpler turbocharger, more reliable turbocharger, the engineers did give us that effective VGT exhaust brake design. Also interesting to note, again, jumping back to generation 1, if you do have generation 1, there are aftermarket products that will put that back into your generation 1. Some people would argue there's some reliability issues in doing that. Kind of depends on the use of the vehicle. Okay, so GT37, we go to a 61 mil compressor wheel turbocharger versus we had a 46 mil in our GT32, but you gotta remember there was 2 of them in there, so something to be said about surface area in there for the size of the turbocharger we had. Still running 6-speed automatic transmission in both of them, same transmission. Still running the same cooling system, very similar EGR system, very similar everything else as far as plumbing goes. Very small changes within our oil pan design. We're going to talk about that in a second. They changed a couple running changes between 11 to 19 in which how your lower or upper oil pan is sealed to your block. And there's some concerns in that we're going to talk about in a second as well with that. But really those are the 2 big changes. Now let's fast forward ahead to 2020, talking about generation 3. Interesting notes in generation 3. We drop our 6-speed, we go to the 10-speed, the new 10R140 transmission. The big jump reason here was for fuel economy. We also pushed the power level between Gen 1 to Gen 2 and pushed it again from Gen 2 to Gen 3. So if you're driving a 2020 to right now in 2023 current, Powerstroke 6.7 liter, there's been jump in power levels each way. Big mileage change though between the 6-speed and the 10-speed automatic transmission. Guys that were getting, let's say the average, including myself, second generation Powerstroke driver gets 15 liter per 100 kilometer, and I'm a metric Canadian, so that's the way I'm going to talk. You might see similar numbers with same truck, same driver, same load, same use, of increases of 2, maybe even 3 liter per 100 kilometer, depending on your use, which is substantial. All because we can keep in that power band. Now the 10-speed doesn't necessarily have to go through every gear. It's going to choose and pick as it wants, but it's capable of always staying in that power band, which means we're never burning more fuel than we have to. Similar plumbing design in the third generation for everything, locations, etc. We go to a electronic motorized version of our VGT turbocharger. So again, another turbocharger change there as well. Same plumbing, basic location. Also the intake manifold design on the first and second gen is aluminum lower, plastic upper intake manifold. And they switched that in third gen. They go to a plastic lower, aluminum upper intake manifold. And they said that was for optimization of heat dissipation within the engine bay, pre and post cooling of the intercooler. So basically keeping the temperatures where they wanted when thinking about heat sinking. We didn't mention the intercooler very much. The intercooler, which is currently located up in the body in this truck, as the cab is lifted just for the purpose of this video, we are no longer running an air-to-air cooler in the front, meaning as turbocharged pressurized hot air goes by it, it cools it and densens it before we put it into the engine. Instead, this time now we run it through a box, about similar size to a small suitcase, which air blows through and we run that low temperature secondary coolant by it to pull the heat out of it. So it is a liquid to air type intercooler heat exchanger. So interesting, that was a first within the North American truck division as far as what we see typically. Again, less failure prone. Typically it is warming up your intercooler air in a cold climate in wintertime, but that's not necessarily a bad thing. It keeps us within sinks we require for all of our proper running emission system on these trucks, keeps them from carboning up as bad as well. So talking about concerns then while we're down here, I'm pointing at one with my flashlight that has become quite apparent, which is part of the reason we're pushing this video. Oil leaks. Yeah, back to our 7.3 days with that old reliable that leaked oil and that was fine. We're back to old reliable in the new generation and we're seeing oil leaks with it as well. So I'm pointing my flashlight there at an area of the engine that is called the upper oil pan. So we see a lot of these oil leaks. I can also use my pointing stick here. Front cover obviously located here in the front of the engine, and upper oil pan starts about this level. Now this truck has just been resealed, which is the reason for the cab up, but the area of the system that typically leaks oil is at that front cover to upper oil pan junction. Now typically you'll see it leak down. As you can see, this one's wet within that area. It's going to leak down and drip on the floor. Interesting is the fact that this is a pressurized passage where the pickup tube in the oil pan is suctioned up to that oil pump area. And when you have a somewhat cavity that is cast into there and an O-ring design across that upper oil pan, which is actually, that upper oil pan is structural to this engine for its strength, you're dealing with areas that are prone to failure. Our professional opinion is the fact that the machining processes on the upper oil pan sealing area, because now Ford has changed back to a silicone only design between upper oil pan and block area, is the fact that silicone needs something to grip onto. With the mirrored machining, we're getting very, very fine machining. That silicone doesn't always have enough to grip onto. These leaks can start small and grow. They can just come on all of a sudden one day. There's really no rhyme or reason for mileage. This truck currently is at 162,000 kilometers, so just outside of its powertrain warranty, be just over 100,000 miles for our American friends in that way. And it was dribbling oil bad enough that it needed to be repaired. So that's something we're gonna see more of. Now, options when it comes to repair on that in a shop, a professional automotive shop that is specializing in these diesels like we do, cab up, engine out is one. The reason for that is the fact that the transmission and engine must be unbolted to make this repair. So removing transmission, lifting engine out of engine mounts and trying to fiddle with an upper oil pan that has a silicone gasket sealed, not the cleanest, most professional way to do it. One slip and you're doing that job twice for free for your customer. You can simply remove engine without pulling cab as well and do it that way on a stand. We've done it both ways. Typically the rhyme or reason will depend on the rest of the vehicle and if the cab is removable quite easily. So it's something we definitely got to keep an eye out for. Other problematic areas you've seen me touch on, we talk about CCV, putting excessive pressure as it is extended past its service life. You get excessive pressure within your oil, low pressure systems. I'm talking valve covers. We see valve cover gasket leaks because of plugged up CCVs, front rear main or crank seals as they're called. We see those leaks as well. Behind this idler, there's a vacuum pump also driven off the engine to create vacuum for brake booster and other areas of the engine. We see those gaskets push out quite commonly in first generation as well, typically all caused by excessive crankcase pressure, simply due to the fact that the truck could either use with a more open flowing crankcase vent or just be serviced more often. Another area we obviously talk about is our dreaded CP4. 2011 was the start of it, still being used in 2023 in Fords. If we look at our competitors, the Duramax and the GM platform, also 11 to 16 uses a very similar CP4 Bosch injection pump in that way, and they have failures. If you're a Cummins fanboy, then you're talking in 2019, 20, and 21, you've got a CP4 as well. Interestingly, Cummins recalled that pump on those 3 models a year and has retroactively put them back to a CP3 as an authorized recall. There are aftermarket solutions as well if a recall is not your style. In Fordland, they have wonderful disaster prevention kits that we use every day here from S&S Diesel and other that allow the injection pump to hypothetically fail but not contaminate the rest of the system. We'll talk about that in another video coming up. And if you are a Duramax user, then your 2011 to 16 has a few options. You can get a lift pump on your 11 to 14 style, like a fast that we do on a daily basis here. You can talk about doing what are called regulators, also called fuel system savers from Exergy and other companies that'll stop any of that metal blowout of that pump as it chews itself apart. Or in Duramax land, you can also go to a complete CP4 to CP3 conversion as well, while staying emissions compliant, which is the beauty of those systems. Fleece is our number one choice for those. So I'm going to hashtag all those companies, and they're going to share these videos as well because we want to all support each other. There's options out there is all I'm saying with your injection system, but leaving it alone and letting disaster come upon at probably the worst possible time is a costly repair. Again, one we do quite often in the shop. EGR system, we're going to leave it alone. Can it be problematic? Sure it can. Is it an epidemic? Not in this generation. Turbochargers, again, we touched on it before. Turbocharger failures are imminent on your 2011 to 14, the original GT32 style, less on the later models. We should also mention that cab chassis, which is your 450 non-pickup and 550 applications, do run a separate turbocharger, and that turbocharger is a much more similar design to your 15 and up second gen pickup style. So no dual sequential and no wastegate on those. Much simpler design, meant to be run at a more steady RPM, and that runs from your 11 right up to 19 as a single part number turbo in that way. So not as many failures in the cab chassis unless the truck's being overloaded, which we see that all the time as well. Again, lots of good information here, guys. If there's more you want to see about the Powerstroke, make sure you hit that like button, subscribe to us to get new content, ring the bell as whatever you need to do to make sure you're getting those updates as we have them. Refer to our old videos that we have. We have a wonderfully extensive library with lots of good information. Most of it brought forth by my team and yours truly here. There's lots there here at DG's Pro Tech going on. If you like this stuff, make sure you tag your friends and share our videos. It's how we all get better within this industry. That's all I got for my long-winded Powerstroke video. Hope I didn't put you to sleep too bad. And really, guys, enjoy, because this is what we love doing.